Hello again and welcome back. Tonight's video we're going to talk about using technology to solve quadratics. And the kind of technology we're going to be using are these lovely TI-nspire CX calculators. Okay, and this one has my sticker on it for my classroom. But these calculators are really amazing. They do a lot of cool functions, including excellent graphing and all kinds of cool stuff like that. But today we're going to be using them to solve quadratic equations. Now there's two ways you can use this thing here to solve a quadratic equation. And one is going to be to use the polytools function, and find roots. And that's the first way we're going to discuss. And the second way is going to be just simply graphing the quadratic equation and tracing to find the x-intercepts, which, as we know, are the solutions. Now, once again, just a quick review. A quadratic equation, the general form of a quadratic equation, looks like this. Okay, that's what quadratics are going to look like. And if we're trying to solve these things, what we're really doing is finding the x-intercepts, these 2 points, or 1 point, or no points, where this quadratic curve is going to touch the x-axis. Okay. So that's really what we're looking for when we solve. Now, of course, we need an equation to solve, so let's go ahead and look at this equation here. It's going to be 2x squared plus x equals 6. Now, remember, if we're actually solving these quadratic equations, we have to dig back a little bit in our review and notice that this thing isn't in standard form. And it's not equal to 0. And those are two requirements, especially for solving quadratic equations. So before we do anything here, we have to make it equal to 0 and make sure it's in standard form. Okay, and in order to do that, I want every term here on the same side of my equal sign. Okay, and right now I have 2x squared term and the x term are all on the same side, but this 6 is all alone over here. So we're going to move him back to the other side, and we're going to use our inverse operations to do so. This is a plus 6. So I'm going to subtract 6 from both sides here. And what I'm going to end up with is 2x squared plus x minus 6. Okay, and what's left on this side? Well, these guys are going to cancel out, and you'll get equal to 0. Now, if you're looking at this new equation that we've adjusted here, it is equal to 0, and you'll notice that the x squared term is first, and then just the x term, and then just the number. So that is in standard form. Now that we have it in standard form, we can turn to our wonderful calculator and tell this machine to solve this equation for us. Now, before we do the polytools roots finder function, we need to know 3 things, and that is our A, B, and C values. Okay, so I'm going to go ahead and list those out here. And remember, this A value is just the number attached to the x squared term. So the A value for this is just going to be 2. Okay. And the B value is the number attached to just the x term with no exponent. And that value here is going to be, you'll notice there's no number there. I say it's the number attached. But if you put your math glasses on, okay, you can see a number floating out here, and that's going to be a 1. So my B value is going to be 1. And the C value is always just the number that's by itself with no variable. Now, this is where I need to specify something really tricky sometimes, and that is to make sure you take the sign with it. Now for the A value, because it's positive, we just put 2, and same thing for the B value, it's positive. But here with the C value, it's a minus 6, so that's going to make our C value negative 6. Okay. Now that we have our A, B, and C values, we're going to go ahead and turn to our TI-nspire CX calculator. And here it is. Now, before we get started using this thing, you want to make sure of a lot of different buttons and features on here, like up here in the home screen, and then over here you have an escape button. Ours are pretty well used, so this escape is kind of wearing off. And then the control button, which will let you use all the orange numbers here. Okay, and then way down here, this is the keypad. Now, the great thing about this calculator and TI Instruments is that they make this calculator so you can use it on SAT, ACT, and tax testing, not tax, STAR testing. So these keys are in alphabetical order, A, B, C, D, not like a standard keyboard. Okay, and you'll notice the most commonly used variables, the X, Y, and Z, are down here at the bottom in white. Okay, so let's go ahead and turn on our calculator. And you'll see a home screen. Okay, now I'm going to adjust this Elmo so you can see it really up close. Okay, so there is the calculator screen up close. And to get started with actually using the PolyTools function on this calculator, we want to first go to calculate. Okay, you'll see a lot of new documents, new my documents, recents, currents. Okay, over here there's a graph and a calculate on your scratch pad side. Okay, and those are the two most commonly used things here. Now we're going to use calculate for this, and it's going to take us to this screen, and you can see I've been using the polyrules solver quite often. So what we're going to do is we're going to hit menu. And I always tell my students to use mostly what class are we in? Well, we're in algebra, so that's probably what we're going to use. Okay, and then you'll notice right here the third option is polynomial tools. Polynomial tools, and since we're trying to solve quadratics, which are polynomials, that's probably the one I'm going to use. And then there's this find roots of polynomials. And when we're trying to solve, we're looking for roots, okay? All the terms used are roots, solutions, solution sets, x-intercepts. They're all the same thing. So we're trying to find roots here. So we're going to go ahead and choose that. And it's going to come up with this degree 2 roots real options screen. Now, if I was solving a polynomial with an x cubed term in it, if I was solving a polynomial with an x cubed term in it, I would change this degree to 3. If I was solving one with an x to the 4th power term in it, I would change this to 4. Okay, but usually your quadratics, especially your quadratics, they will only have an x squared term. Okay, so that means that our greatest exponent is 2, which means we're going to leave this degree 2. And this is just asking what kind of roots am I looking for? Am I looking for real roots or complex? And those are the only two options given, and we're always going to be looking for real roots. So I'm going to choose OK, and it's going to come up with this nifty screen here, this what is A2, A sub 1, and A sub 0. Okay, it's asking for what those three things are. And if you look up here, it gives you a little guide, A sub 2, x squared, plus A sub 1, x, plus A sub 0 equals 0. Okay, and so you can see that this A sub 2 is just the number attached to my x squared term, or what we call A. And so for our equation, A was 2. Okay, now I'm going to go down to the next one. And it's saying, what is A sub 1? Okay, and we can see here, A sub 1 is the thing attached to the x variable with no exponent. And for us, that's the B value. Okay, so we're going to go ahead and put 1 there. And then down here, it's going to say A sub 0. And that's just the number attached to the end there. Okay? And this is where we're going to put our -6 in. Now, here's where I have to branch off and tell you that computers are stupid. They are stupid machines that will do exactly what you tell them and nothing else. So if you forget to pull the negatives here, it's not going to give you the answer you want. It's going to give you the answer it thinks you're looking for. Okay, so if you ever run into an issue where you think that may not be correct, I would definitely go back and look at your starting equation and see if you got all the signs right on these three numbers. So once we enter all those, we're going to hit OK, and it's going to populate this polyroots tool here with an equation. Now this equation, this 2 to the x squared plus x minus 6, should exactly match the equation we're solving, okay? And if you look back at the equation we were looking at, it is 2x squared plus x minus 6 equals 0. So it does exactly match. And then this last piece, it says comma x. Well, in the programming language, this is telling the calculator what to solve for. We're finding x roots. So if I wanted to change this function here in here to 2t squared plus t minus 6, I would need a comma t there, okay? Because our variable in this equation would be t, and I want to tell it to solve for t, okay? But, you know, we're using the standard x, so this will work just fine. And the last step is just to hit enter. And it's going to come out with the two roots are -2 and 3/2. And so there you go. That's how to use the polyroots function on this calculator. Now, I want to point out something you may come across every now and again. If we go up in my history here, just pressing the up key, you'll see in this one, when I did this particular function here, solve for x, it gave me this parentheses empty box. And a lot of you may come across that and go, well, the calculator isn't doing what it's supposed to do. Really, it is. It's telling you there are no roots. Okay, that's what this box means. It means no real solutions. What it's telling you is that graph doesn't actually cross the x-axis. So there are no real values to solve for. Okay. Now, the second way we might want to solve this is by using graphs. So if I hit my home button here, and then I go to new documents, and if you ever have something open, it's going to ask you, do you want to save the unsaved documents? And usually I always say no. Okay. And then it'll start here and it'll ask us what kind of document we want. Well, we're trying to graph something, so we're going to choose graphs. Okay. And it's going to come up with this asking us what f1 of x equals. Now, if you think back to the beginning of algebra, you'll know that this f1 of x is just saying y equals. Okay, it's the same thing. Okay, and what we're going to do is type in our function. Now, if you remember, our function is 2x squared plus x minus 6 equals 0. So I'm going to type in 2x and then the squared function plus x minus 6. Now, this is where you want to make sure it's a little different. You're not going to put the equals 0 here, okay? Equals 0 just means solve for the intercepts. Here, we have f1 of x equals, okay, or y equals this function. So I want to graph the whole thing, not just the equals 0 part. So I'm going to leave the equals 0 off, and I'm going to hit enter. And it's going to populate with this lovely quadratic curve here. Look how wonderful that is. Okay. And I'm still trying to find the roots, x-intercepts, solutions, solution sets. Okay, I'm still trying to find that thing. All right, so I want to know what values is this curve touching the x-axis? Is y equal to 0? So I want to know what this spot right here, where it crosses the x-axis, and this spot is right here. So I'm going to hit menu, and then we're going to choose trace and graph trace. Now 99% of the time when you choose this graph trace function, it's going to start to trace this little identifier on the y-intercept, and that's fine. It's just telling you where the y-intercept is. But we're looking for x-intercepts, so I'm going to use. A lot of us are tempted to use the up and down keys in order to move this thing, but you're always going to use your right and left keys. Okay, so let's go ahead and do that now. I'm going to use my right key, and I'm going to go over And oh, look at that. It tells you there's a 0. Okay, and I want to know what that 0 is. Right down here at the bottom, 1.5. So that's going to be one of my roots. And if we go back the other way, there's the y-intercept and the minimum. We'll get to that later. If we keep going, oh, there it is, -2. So that's my other x-intercept. And that's another way you can solve, okay? So that's going to tell us that the two roots are -2, and this one, if you remember, was 1.5 or 3/2. And that's it for solving quadratics using a TI-nspire CX.